Hello all, this is the fourth video for the BSL and BST sheets. As always, please watch the Anatomy of CRL series videos for a general overview of CRL sheet shared functions. In this one, we are going to be, let me restart here. We're going to be copying inputs from LAMI. We're going to be going through the CRL parts itemizer, getting a little more in-depth with CR Lawrence and taking a look at their catalog, which I find despicable with the update. You just have to go through. I don't know what they're doing with it, but luckily you have this program, so you don't have to go through the catalog. So we'll be readjusting the sizes here to get the correct weight, and going through here and adjusting the heights for the system. So let us do it here. Copy input from LAMI. What that does is copies just the user-defined inputs with the gradient background. Just to demonstrate again, if you can plug in whatever you want here. If you want to reset the formulaic values, you can hit that button there to get you back to square one. Okay, so first off, the heights are ridiculous. We want to get them around 48. We'll put a 42 in there for some reason, and maybe a 56. So we have here the weights. Generally, I try to get the widths and the quantity down, the widths up, to get this around 150. All right. So all 66 lights are well below 150. So let's cut these quantities in half and see where we are. There's 60. We'll go with a 4. Go with a 10, and this definitely shouldn't be 1. Shouldn't be 2. So nicely, we have our weight up to 150 without really going over. So we're still within a 2-man light. The OSHA standard is 75 pounds. So that is looking good. The caulk is usually like this. I've done some videos that I screwed up, so that's how it would come. We're going to get rid of the butt joints. We're going to confirm our polished width of 1, which is the top, and the vertical heights, with the 1 captured not being polished. We have here the availability of tapered as well. I'll just show you what that looks like here. This would be a fascia mounted. I think tapered is coming up. There's a tapered. So the end caps are going to be different. The cladding is different. The mitered is going to be different. Stuff like that. So there's the tapered. It's only available, I believe, in 1/2 inch. If we go to 5/8, tapered is not available because it shows NA, and nothing is chosen here that is in the given DDLs. So everything will be fixed if we go there. 5/8 does not have a 20-foot base shoe. So let's do a fascia. When I switch it to fascia, these go to 2 because it's more difficult to lay it out and set the bolts. We'll put a utility in of here, 5,000. Let's come down here. Let's get right into it. Let's do a optimize. Well, let's put it to standard. Well, what am I doing here? This needs to be 1/2. 1/2 is generally what you're going to be working with. So 1/2 has 20 foot and 10 foot. We're going to optimize both of them. So now we have twice the amount of metal, and this reacts to it as well. We have twice the amount of cladding and twice the amount of base. So because 7,000 is more than 6,700, we're going to delete BST 20, puts it back to 0. Now we are even Steven here. We are going to figure 90 degrees, and we're going to move that from 10 to 6. With tempered, we have the choice of 100 or 500. We're at 990 with 100. We're going to go to 500 and see that it's more. So we'll go back to 100. 20%, I like to keep that on there. Maybe we'll move to 10. This is figuring the substrate, and here are the taper locks. This is on choose because we're not doing a cap. If we want to open it up, we can do that and make sure that these are all chosen and this is populated. On the previous one, we had the availability of a 14-foot and it was a 10-foot. So this is the main reason why I didn't include an optimization, because of the variables here. So this, go to the second video to watch how a manual optimization is figured to create this sheet. But this one's a little simpler. We're not going to be doing a cap. We got rid of the caulk. That's basically it. We've gone over this before. I'm going to add the spandrel equals, this one's going to be spandrel. So that then populates this, and I've already done this to just show that you can change these on the fly. We're going to go with a 85, and we're going to say just to demonstrate you can put in whatever you want. The light's in purple, so we're just saying that it's going to be 1/2 inch tempered, and we're going to put a rake in there. 5. Let's move this to 5. Anyway, I'm kind of screwing it up here, but the lights in purple are to have a rake as well. And there's your RFQ. I do like to mention this from time to time. This is asking for your due date for the CRL to be 2 days prior to the project due date of Friday. That is 2 working days. So if I do 5, it'll go to the Friday before. Very cool. It skips over the weekend. So we're going to go 2. I'm going to demonstrate that because this is on standard or tapered, these are the same. You're just turning them around. There's the same extrusion. I'm going to demonstrate how the RFQ will eliminate one of them and double this value to 46. And there goes 23, 46, 13. I'm not going to show you what the RFQ looks like, as it is exactly this. All right. And it's wasting time opening up Bluebeam and everything. So once you hit that OK button, it'll revert it back to 23, 23. Just show it's the same here. Okay. Let's just go through. The prices are still the same here, which is nice. CRL Lawrence seems to retain their prices well. And just let me know if the prices are off. And the way you check that is by going on individual totals and ensuring that this value is somewhat close to your quoted value. So we have here a price of, I forget what product number I put in there. But you can just copy these in and put the part number right in there. So we're at 295, 241. It looks like that price has gone up. I checked the cladding here, and it was the same. So just let me know, and I can update that rather easily. I just got to go into data here and go through. I'm protecting this for my own intellectual property, as well as, you know, most people won't really know how to do this properly. But these are all the sheets that it pulls from. Pretty cool, huh? So yes, make sure that you call me to update it. Once again, it's really just a check. The CRL database is a check to make sure that they're not, have anything weird or you request it improperly. And 3 or 4 times a year or whenever requested, I can update the CR allowance prices to make sure that your database price here is the same as your quoted price here. Okay, I'm going to go back and see if we have anything. That's pretty much it. I'm trying to think of anything else. I don't really see a reason to go through this again. We put in the caulk as something other than open. The cap is zeroed out because we have choose down here. Unload truck layout, bolts percentage, 100% because there's no caulk. Let's go to final and see what our price per is. Price per linear foot is $378. Labor is at 50/50, which is reasonable compared to this. This is where the material would be a lot more. $12.45 seems like a lot. I did go through the numbers. Generally, that's going to be around 1,000. I'm just going to cut this a little bit, see what it comes out to. Yeah, so that height will really adjust it. That brought it down, I think, about $150 per square foot. $378 per square foot translates into 94 per square foot. That does seem a little high. Just plug in your numbers and see where it comes and adjust your labor accordingly. Thank you very much.